Yep. Vertex form for the first time, it's one of three forms of our quadratic equations. And in each form for our quadratic equations, there's like pros and cons. There's things you can see better in one form versus the other. So in vertex form, what's really easy to see? The vertex, that's why we call it vertex form. Here's that equation. Note that I am not providing it to you on the test. This is something you would need to memorize. Which if you make a flashcard, that's pretty easy. Like make a flashcard, make 10 of them, probably is what you would need for this unit. It's not like when I was in college and I had to memorize over 200 things each week for my tests. Not math tests, but still like I would have to make like 200 flashcards. I would have them on Quizlet on my phone and it would consume my life. For this unit, you maybe need like 10. So please like consider it's a really good study skill. Make the vertex formula one of those flashcards, memorizing. So that is it. What letters give me the vertex? H and K. So then table 3, what's my vertex of this equation? Okay, class, what do you guys think? 3, 2. 3, 2 is what it's actually. But do you see the 3 and 2 in the equation? Yeah, I actually did. So that's what you should easily see from vertex form. You shouldn't have to do any calculating. It's just there. So H is always in parentheses with the X, and it's always opposite of how it looks in the equation. If it's a positive 3, that means in my equation, I plugged in a 3. And then the K is always outside, not in parentheses with the X. It's always being added or subtracted. And that matches the same symbol. It's like your y-intercept. Not that it is your y-intercept, but it's like it, how it's like separate. Questions on that? Okay. So that you should have on your graph, the coordinate for you two. Also pay attention to how they're numbering it. The tick marks on the x-axis go up by 1. The tick marks on the y go up by 2. So 3, 2 is this. Now, this one, I heard some people were kind of struggling with. And I know some people would go to Desmos and just try to see what they can find. On your test, you do have a graphing question by hand too, like on your constructed response tests. On your practice test, you can even see it. It's going to be a 4x4 coordinate plane. So you would need to plot points that are on that graph. And what I usually see a lot of the time is maybe one point is right, and then the rest is just like that. Like no actual touching any of the actual points that it should touch. So you just kind of look at Desmos, do a rough sketch and move on. That would not get you the point. So stop using Desmos as a starting place. Use it to maybe check your answers. Remember that you don't get Desmos on your state test. So that's why additionally you need to know. So table 4, can you tell me a point that you put is on your line? For number 2, it says find the coordinates of 2 other points on the graph. What's one of the points? 0, 3. We'll see if that's on there in a second. Table 5. What's another point you picked? Okay, we'll come back to you. Table 6. What's the point that you said is on the graph?
Oh, well, I think I know the X is 6, but I don't know what the Y is.
So like we have an x-intercepted 6. Is that what you're saying? Okay. Anyone else have one they want to add? Okay, we'll see if those are even on there. They might not be. I don't know. check those points. But here's how you can find a bunch of points on the graph. They give you the equation. And now you know where your vertex is. You can plug in x's into the equation and get values for y. And when it's a quadratic, having the vertex is especially helpful because if I want to see that U shape, I would put the vertex in the middle of my table of values. And I would pick x values that are near the x of my vertex. So what are some numbers near 3? 4, 2, give me a couple others. I heard 1, and what else? Maybe 1 on this side, 5. You get to pick the x's, and I would pick it based off what my vertex is. So if my vertex is like, I don't know, -7, 3, I'd pick numbers near -7. So that I can see that U shape on my graph. Then you're plugging in these x's in your equation to get your y. I would use a calculator for that. But at least that way you're not just like clicking and dragging on Desmos. That way you are getting things that would actually be on your graph. So if I plug in the 1 into my given equation for the x, it becomes 1 minus 3 in parentheses squared plus 2. So I'm plugging it into my given equation. When x is 1, my output is 6. When x is 2, my output is 3. When x is 4, my output is 3. And when x is 5, my output is 6. And that I can graph and make a nice U shape. That's what you should do probably under constructed process, is make a table of values. Let's see if those other points you guys said are actually on the line. So if I plug in 0, I get 11, so this one is not on the line. Not 0, 3. If I plug in 6, I get 11, so that one's not on the line. This is how you can get values that are on your line, is by plugging them in and getting those paired values. Questions on that? Okay, so now you can plot those to make that nice U shape. So 1, 6 would be here. 2, 3 would be there. 4, 3 would be there. And 5, 6 would be there. So if you're picking them based off of your vertex, then you should see them start to kind of like parallel each other. And then you can make your nice U shape. Yeah. So when I grade your test, I'll be looking for, did you actually plot points that are on the line? Or did you just scribble? That's basically how it goes. So questions on that? Use Desmos to check your answer, not as a starting point. So this is our last lesson of Unit 6. Mostly just review about Vertex form because we covered that yesterday. So let me just briefly read you and remind you of some things. All right, I record every day. I was just talking to some other teachers, like, it's very unusual for teachers to like record their lessons and post them. I don't know another person that always does that other than me. So it's just so much better for me to tell you everything that you need to know about that subject. That's why I put it online for everyone to watch. But if you're absent, I'm not just trying to get you caught up in like a 40-minute tutoring session so that you know everything you need to know. So whether that's for one day you're absent or I don't know, 15 days that you're absent, you need to know the stuff to be able to do the best you can on the test. So there, it's all there, all of it. Puzzle piece is lesson 17. And we do have a binder check tomorrow. Here's everything that would be included in that. And if you are missing one of the pages, you could take the notes from Schoology, copy them onto your own paper, or you can go get them from the bin and fill out the notes from Schoology too. It's all there. There's no reason we can't all get 100% on it. Like the bare minimum requirement is you taking notes. Without you taking notes, having a good 20% of your grade category, the highest grade you could get is an 80%. And that's just you getting 100% on everything else. Homework, tests, everything else. So really like the highest you'd be able to get is a C if you just like don't take notes. So please take notes, have them ready tomorrow by the time you walk in. That way tomorrow, all you have to do is work on your study guides and ask questions on that. Also during the binder check, I'll check your practice constructed response test. I gave it out yesterday. So if you need it, it's in the bin. I'll also recheck your coloring activity if you did more than the last time I checked it. Questions on that? So the study guides both are available. I didn't put a slide to tell you that, but they are right at the top of Schoology. You can't miss it. Even the 100 points study guide is available too. And it's not extra credit, it's required. So this one is worth 100 class points to match the 100-point portion of your test. This one's worth 50 class points, and that's the 50-point portion of your test. You always take the two portions within the same hour. So one's on paper, one's online. That's what your study guides are set up to match. Questions on that? So there's that. Moving on with the rest of the things we need to cover. We're gonna do a card sort. So in your baskets, you might find 1 or 2 sets. Hopefully none of my students mix them up. The backs of them have numbers so that if they did get mixed up, you know which set goes with which. But you could do like pairs of 2, or you could all work on it together. You're matching the equation to the graph. Preferably without Desmos. Like if you finish way early and you have extra time to check, then sure. But it's also on your paper, the graphs and the equations. I want you to put your final answers, probably when we go over them, on the paper. Right now, you can sort with like the little cards. So any questions on what you're doing? Okay. So get to it, try not to use graphing technology, maybe just to check your answers at the end, matching the equation to the graph. I'll set a timer for like 5 minutes. Okay, B goes with which one you said? Okay, everyone else pay attention. We're gonna see if H of X truly goes with graph B. So what's the vertex of H of X, this formula? Are there any others that have the same vertex? So now I'm not talking about the graphs, I'm talking about the equations. Do any of these other equations have the same vertex? R of X doesn't. E of X does. So there's 2 that will have the same vertex. See how these equations are different. One of them has a positive A, the other one has a negative A. If it has a positive A, what direction should it open? Up, up like a smile, like when positive things happen, you smile. So H of X does go with graph B, that is a true match. Table 2, can you tell me a match that you made? F of X goes to F. F of X goes to graph F. So let's see. Graph F has a vertex of 1, 4. Do we get that from the f of x equation? Yes. Let's make sure that none of the others could give that, because then we might have to check those. And I don't see any others that do, so that is a match. F of x goes with graph F. Questions on that? Okay. Table 3, give me a match that you made. Okay, Q of x with graph C, let's see. What's the vertex of Q of x, class? 4, 1, so remember. This part is always opposite of how it looks, this part always matches, so 4, 1. And graph C also has it at 4, 1. But are there others that have the same vertex? Which other one has the same vertex? So let's compare these two formulas, how they're different. This one has a negative A, this one has a positive A. If it has a positive A, what way does it open? Does graph C open up? So this one actually goes with G of x that has the same vertex, but it opens down. So G of x goes with C. That means Q of x goes with which one? Table 3, you want to redeem yourself? Which other one has a vertex in the same spot? No, like the graph. Which other one has a vertex at 4, 1? I have them on the screen too. Graph A, good. So graph A goes with Q of x. Because it has a vertex at 4, 1, and it opens upward. Questions on that? Okay. So then table 4, is that, tell me which one goes with P of x. Graph D, so let's see, it is at -1, -4, and it opens downward, so that is a correct match. P of x goes with graph D. So then process of elimination, R of x goes with graph E. And that vertex is -4, -1. Does that make sense? Any questions? So this one was supposed to be tricky because they all have 4s and 1s. But you can tell based on the vertex and what way it opens, which one is the true match. And then on your test, of course, you could use Desmos to check your answer, but you need like some of those fluent skills as well. The next thing I'm gonna have you do is on the back, there's some questions. It's basically like 5 questions total. You're gonna try them out yourself. Or with your group is fine too. But it's asking you kind of like as a check for understanding. If I'm starting with my parent graph, x squared, what's the vertex of y equals x squared? Oh, pay attention, everyone look at me. Our parent graph, the x squared, the most simple one that we could have, the one that we started with for all the transformations we looked at the past 2 days. Where is the vertex of x squared? 0, 0. So if we're starting from our parent graph, which starts at 0, 0, and our new vertex is 0, 11, 7, 11, 7, -3, you need to tell me how it changed. Did it go up, down, left, right? Did it reflect? That's what you're doing. If this is my new vertex and it opens in this direction, what was the change? be able to tell me that. For the next part, it gives you a couple things to do, like sketching when it's in the vertex form. Giving you the transformations, like that it's shifting to left, 10 down, flipping, and asking for the equation. So these all on the backside are all really good test questions. They all test like you understand the transformations. I'm gonna give you a generous amount of time to try them. So maybe even like 10 minutes. We'll go over them in 10 minutes. When and if you finish early, you can work on your practice, but you need to give this a fair shot. Any questions right now?
About this.
Yeah.
The back out. Those regions, okay.
Yeah, so this is for my parent graph. This is the vertex of my parent graph. My parent graph will look something like this. And now if I'm saying that my new vertex is 0, 11, how does that graph change? That's what you would say right here. It's just up 11. And then is that the only change for that one?
Yeah.
So then we move on to the next one. And that's what you're doing. Good, any questions? Okay. So I'll leave you to it then. Hi, for 1B, 7-11, how does, or also let's go back to 1A for a second. Can you tell me what the equation for 1A would be if we know it shifts 11 up? Okay, good. I would just condense that to just x squared plus 11, because normally we don't write plus or minus 0, we just write that number, but yes. If it's going up 11 and that's all it's doing from the parent graph, then we just add an 11 to it. We don't put it in parentheses with the x. So table 6, 7-11, what is the change to the parent graph?
Moves right 7, moves of 1.
Okay, good. Moves right 7 and up 11. So if you want to use the same graph over here, 7-11, that coordinate would be somewhere over here. Rough sketch, going right and up. Table 1, what would be the equation if it's going right 7 and up 11?
It would reflect down to each right seven.
So for 1B, what would the equation be?
Oh, it would be y equals x minus 7. Plus 1.
Okay, good. So when it looks like x minus a number in parentheses, it's going to the right. And then we already talked about that one. Table 2, how does the graph change when the vertex is now 7, -3? From our parent graph.
Right.
Okay, right 7, and then you're going with left 3.
No, what?
Down 3. Okay, and down 3. And then what about it opening downward? What would have to change? Or like, how do we call it when it flips? Would do? How do we make it go down? What do we call it when it goes down? Somewhere like that. Table 3. When it goes down, what do we call that in math? Well, something will be negative, but what I'm asking you is what it's called when it flips. You don't just say it flips, we say that it does what? And reflects over the x-axis. And yeah, so from our parent graph, 0, 0, if we're going 7, -3, it would end up here, so we are going right and down, but then now we're making it reflect. So table 4, what would the equation have to be for this one? And is that all? What's one more thing that I need in it? Like a negative symbol in front of the parentheses right here, because it also opens downward, so it needs to have a -a. They didn't say anything about it getting more narrow or more wide. So we don't need to make A anything other than 1, but we do need to make it negative if it's gonna reflect. Questions on that? Okay, so then the last part, the cool down. Hopefully you can sketch from the Vertex form. So table 5. The first one of the cool down. Let's start with what the Vertex is. So from the equation, what's the Vertex? Six, 10. So when you made your sketch for this one, you should have a point here. Pay attention to how the axes are labeled. 610 would be there. And then it didn't say anything about it stretching, compressing. A is not negative, right? So it should still be like the same size. It just now has a new vertex. At 610. Table 6. For the last one, it gave us a list of transformations. It even showed us the transformation. You had to make the equation. So if it's going 2 to the left, 10 down, and flipping, what should the equation be? Okay, perfect. For the last one of the cool down, if it's going 2 to the left, that would be you doing x plus a number in parentheses. That's like a really important thing you'll need for the test. If it's in parentheses with the x before being squared, that's left or right movement. And if it's plus a number, it's going to the left. Outside of the parentheses, if we're adding or subtracting, that's up or down movement. And then if it's reflecting, then it's negative in front of the parentheses. Okay? Questions, comments, concerns? All right, then that's all I have for you. You have a really good amount of time, more than any of my other students had all day, to work on your practice and your study guides, because the study guides are also available. You can even use the time to get your binder text ready for tomorrow. Things like that.